want to simplify square root of 63, so we can break that into a perfect square factor of 9. 9 times 7 is 63, and the square root of 9 gives us 3, so we get 3 square root 7. When you take the square root of a number, it'll come in front, and then whatever is left underneath that will stay underneath. Number 2, square root of 32 times square root of 4. One way of thinking about it is 32 is the square root of 16 times 2. And then the square root of 4 is just 2. Square root of 16, that's 4. So we get 4 root 2 times 2. You're going to multiply the numbers in front, so you get 8 square root 2. So that's one way. Another way to think about it is to multiply those together, and you get the square root of, from the original, square root of 32 times square root of 4 is square root of 128. And then you could split that up into square root of 64 times 2. Square root of 64 is 8. So you get 8 root 2 either way you work it. Number 3, multiply those together, you get the square root of 400, which is just 20. You could have done it in parts if you saw 50 as square root of 25 times 2, and then that gives you 5 root 2. And then for the square root of 8, you could have written it as square root of 4 times 2. So you get square root 2 square root 2. And then you would multiply the numbers in front and get 10. Multiply the numbers underneath the radical, get square root of 4. Square root of 4 is 2. 2 times 10 gives you 20. So either way you should get 20. Number 4, the square root of 81 is 9. Square root of x to the 8th. Remember, the index is 2. So when you're looking at your exponent, it's kind of like division. 8 divided by 2 is 4. X to the 4th times x to the 4th is x to the 8th. So the square root of x to the 8th is x to the 4th. And then y to the 12th, the square root of that is y to the 6th. Again, it's kind of like taking 12 divided by 2 as far as your exponents. Number 5, we can rewrite 48 as 16 times 3. Square root of 16 is 4, so 4 is in front. Square root of 3 is still underneath the radical. And then the square root of x to the 14th is x to the 7th. And then the square root of y to the 18th is y to the 9th. Now we want to make sure that the answer here is positive, because if you look at the original, you have the positive square root of all that stuff. So we want to make sure that our final answer is positive. Well, x itself could be positive or negative. Same thing with y. So if we want those to come out to be positive, we're going to put the absolute value around that. So no matter what, x to the 7th times y to the 9th, no matter what x and y end up being, we need that to come out to be positive. And then the positive of that times the positive 4 times the square root of 3, positive square root of 3 would all make it positive. So if in the original, if you have even exponents, and then in your answer you see an odd exponent, then you will have to have absolute value. Again, if you see an even exponent in your original problem, and then an odd in your answer, you need absolute value to make sure that they come out to be positive. Number 6, we can rewrite 300 as 100 times 3. And so square root of 100 is 10, so 10 is in front. Square root of 3. That 3 is still underneath the radical. Now you can think of that index as a 2. 2 goes into 7 3 times, so we have x to the third. But then you're left with x to the first power. 7 divided by 2 is 3 with the 1 remainder, so x to the first power has to stay underneath there. And then the square root of y to the fourth is y squared. Now this time we had an odd exponent in the original problem, so we don't have to worry about the absolute value. And then on the y's we have even and odd in our final answer, so we don't need the absolute value. Here we want to find both x and y. Looking at the x first, I should have given you that this was a right angle. So if you know that that's a right angle, then you'll be able to figure out the angle. So that would be 90, and then you've got an isosceles triangle, so these sides across from the congruent, these angles across from the congruent sides have to be congruent. And so x has to be 45 degrees. And then to find y, we'll do y squared equal to 16.2 squared plus 16.2 squared. And so we'll square both of those, and we get 262.44. And then we can add those together. And so y squared equals 524.88. To get rid of squared, we'll square root. Only a positive answer makes sense. And so you get approximately 22.9. Now it just works out on this particular one that 16.2 times the square root of 2 is also, that would be the exact answer. So we found both x and y. Here we want to decide what type of triangle is formed by this, so our choices based on the angles would be acute, right, or obtuse. So the biggest one would be considered C. So we're comparing 11 squared with 6 squared plus 8 squared. So 11 squared 121, 6 squared is 36, 8 squared is 64. Add those together, you get 100. And so 121 is greater than 100. So 11 squared is greater than 6 squared plus 8 squared. And so therefore it must be an obtuse triangle. Now if we were just classifying based on the numbers by the side lengths, we would say scalene, because all of the side lengths are different. But what we've been doing in this section with the Pythagorean theorem is classifying based on their angles. Alright, we know that AC here is 20, so we'll do the Pythagorean theorem. The sides that we don't know are the same, so we can say 20 squared equals x squared plus x squared. So we have 400 equals 2x squared. 1x squared plus 1x squared is 2x squared. To get rid of multiplying by 2, divide by 2. So we get 200 equal to x squared. To To get rid of squared, we'll square root. Only a positive answer makes sense. And so we can rewrite that as 100 times 2. And so we get 10 root 2. So that's the exact value of AB.